Okay, so this is the question here. The following data represents the sales for a company in the year 2025. All right, so we've been given this information, which represents the sales that the company made the year of 2025. So we're going to analyze these sales so that we can find the mean, the mode, the median, and the standard deviation. All right. So the first part of the question. Okay, it says first find the mean sales. So the mean is like the average. Okay, what the mean is, basically it's a number that describes the data set. You want to describe a data set with one number, that is the mean. But in this case, for this question here, the mean would be like the general performance or the average performance for the company. All right. So this is the formula for the mean, which is here. Usually with statistics, these formulae will be given to you in the exam. Okay, so you don't need to memorize them. All right. This is the formula summation of x over n. What this E means, it means you're going to add up all the data values. Okay. The data values are represented with this x here. Okay. These cells here are represented by x. So we're going to add up all the cells. And after we add up all the cells, we're going to divide by the number of cells that we have. Okay. These cells are for 12 months. Okay. There are 12 numbers here, which represents 12 months. So N is just the number of data values. In this case, the number of cells that we have in our data group. All right. So first thing we need to do, we need to add up all of these cells. So let's get our calculators. We get the total of the cells, and then we divide by the number of the cells. Oh, let me just bring the numbers here. So we're going to say 17 plus 18 plus 18 plus 19 plus 19 plus 21 plus 21 plus 21. Let me see how many 21s. 1, 2, 3, 4. 4 21s plus 21 plus 22 plus 22 plus 23. And then n, since there are 12 numbers here, so n represents is equal to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. So when we add these numbers, colleagues, what do we get? Anyone who has added up the numbers? 224. Okay. 242. Okay. So, colleagues, no, there is no way. No, there is no way. 22, 23, and 24. What calculators are we using? 242. Okay. So I've heard 242 two times. Okay. I just want to hear the third person at least so I can make sure. I'm feeling lazy to add, okay, colleagues? I'm feeling lazy to add. But let me add maybe also. 242. Yes. So 242. So divided by 12, 242 divided by 12. Come again, sorry, I never heard. 20.16. Is everyone getting that? Okay. So for this company, this is for that year of 2025, the average sales were 20.16. Okay, that's what they made on average. Any questions? All right, wonderful, wonderful. We now go to the median sales. So the median is basically just like the middle number of a data set. Okay, to tell you the number in the middle and to tell you that 50% of the data values are above that middle number and 50% of the data values are below that middle number. Okay, colleagues? But the median basically is just the middle number in your data set. All right. So to get your median, as I said, if you've got a small amount of numbers like this, you just want to find what is the number which is in the middle. Okay, so the first method you can use, I call this the cross out method. Okay, you cross this one out, you cross this one out, you cross this one out, you cross this one out until you reach in the middle. Okay, until you reach the middle. So you use this method when your data set is a small amount of numbers. Then I'll show you the other method if your data set is, if you've got a lot of numbers. Okay. So in the middle, we have two numbers here. Okay. In the middle, we have two numbers. So we're just going to add them and then divide by 2. All right. So 21 plus 21, that is 42. 42 divided by 2, that is 21. So our median sales are 21,000 kwacha. So 50% of the sales are above 21,000 and 50% of the sales are below 21,000. Any questions? Another way you can locate the position of the median number, okay? You can also use this formula for percentiles. Okay, this percentile formula can help you find median, upper quarter, lower quarter. Okay, so let me just show you how we can use this formula. Our median is the middle, so it's the 50th percentile. All right, so if we use this formula, n plus 1, let me just bring it near the data set. Yes, n is 12, so it's a 12 plus 1. P represents the percentile. So since the median is in the middle, so it's the 50th percentile. So 12 plus 1 multiplied by 50 divided by 100. So 12 plus 1, that is 13. 13 times 50, colleagues. What is 13 times 50? It's 650. 650 divided by 100, 6, 6.5, right? 6.5, yes. So you come to your data set here and you look, where is the 6.5 position? One, two, three, 4, 5, 6. So 6.5 is between 21 and 21 here. That is the position of your median. Okay. Then also there's another way you can also find it. Okay. There's another formula you can use to find your median. Right. You can also use this formula here. Okay. Let me just put it there. You say half, then you say n over 2 plus n over 2 plus 2 n plus 2 over 2. All right, so say half. N is 12, so you're going to say 12 divided by 2 plus, then you say 12 plus 2 divided by 2. 12 divided by 2, that is 6. 12 plus 2, that is 14. 14 divided by 2, that is 7. 6 plus 7, that is 13. Half of 13, 6.5. Okay, colleagues, many ways of doing this thing, all right? Many ways. So with these two ways I've shown you, to give you the position, then you find the position in the data set. But if you've got a small data set like this, you don't really need to apply these formulae. Okay, unless maybe you're given 30 numbers, 40 numbers, then yes, you can apply these formulae. Yes. Any questions, colleagues? All right. Next, we have to find the model cells. So, colleagues, remember the mode is just the number that appears the most. Okay, so in this context, it's the cells that we made the most in that year. All right. Mode is the number that appears the most. So for the mode, you just look at your data and you say which number appears the most here. Colleagues, which number appears the most here? 21. Okay. So that year in 2025, since these are sales for each month, so in 4 months we made sales of 21,000, 21,000, 21,000, 21,000. Then now the sales then started to change. Any questions? Okay, wonderful. Next, now we need to find the standard deviation. The standard deviation tells us how far the data points are from the mean, basically the spread of the data. Okay, how far the data points are from the mean or the spread of the data. Okay, want to see basically in this scenario in 2025, were our cells stable near each other or our cells fluctuating far from each other? But already from this, the way it looks here, you can already tell there's a small standard deviation because you can see the cells are really close to each other. They're not very far apart from each other. They're really close. So you expect a smaller standard deviation. Okay. So just here's a picture to show you what this standard deviation talks about. As you can see here, the mean is this green line. So if you have a small standard deviation, the points are near the mean. You see? But if you have a high standard deviation, the points are very far from the mean. So this is how we get the standard deviation. Now there are two ways. Okay. You can either use this formula here or you can use this formula here. Okay. Because when you start doing your own research, going through YouTube videos and books, certain books will give you different formulae. Okay. So I want you to be aware that there are two different formulae we can use. All right. So I will show you how to use both of them. Okay. Show you how to use both of them. So we can start with this formula here. All right. Here, n represents the number of data values that we have. Here, we're going to square each of the cells and add them up. Okay, this summation x squared just means your data values. You're going to square them. Then after you square them, you're going to add them up or you total them up. Minus 1 over n, which is the number of data values, open brackets. Here, summation of x, this 242 we got here. We're going to square it. So let us start squaring. So what is 17 squared? We have to square all of these values here. So 17 squared, what is it? Then we have to square 18. 18. Can someone give me the square root of 17? Okay, thank you, madam. 289. Yeah, 17 squared. 18 squared. Okay. So we've got 218, so 2 324s. 19 squared. Okay, 21 squared. So 441 here again, 441 here again, 441 here again. Okay, then 22 squared. 484. Then again 22 squared. Oh, 484. 484, yeah. Okay, then 23. 23, 23 squared. 529. All right, colleagues. Yes. Let me make sure they're 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So now we get the total. Okay. These squared parts, we get the total. When you add all of them up, what do we get? 4,559. Okay. Somebody to confirm. All right. Wonderful. Okay. So after you have done, because this is the only work that you need to do. After you have done this, now it's just a matter of substituting into the formula. Okay, so you have 1 over n minus 1. So n is 12. So 1 over 12 minus 1, open brackets, summation of x squared, this 4,559 minus, okay, here. So this summation of x squared, it's this 242, which we got when we added the cells. Okay, when you added the cells, the total cells was 242. So I'm going to say 242 squared divided by n, which is 12. Mhm. Okay, let's see. Hey, so those were finding at 4,559, 4,920. So it's 4920. Okay. How many are finding 4920? You can just do a thumbs up. 4920. I haven't seen that. Sorry. So it's 4920. I'll add up also when I've got free time. So we'll go with the 4920 unless the number is otherwise. Or let me just add up, okay, so that I just confirm so that when you're studying, I'm not getting calls at night. Sir, may I found a different fig. Yes, I'm getting 4920. I'm getting 4920. Yes. Okay, so let's do 242 squared. Yes. Mhm. Oh, 1 over n times 242 squared. You can write it like that. Okay. It won't change anything. You can write it like that. If you want, you can put this over this one here. Okay. Yes. So thank you for asking that question because maybe others worried, how come it's coming on top? So, colleagues, you can write it either 1 over 12 times 242 squared, or you can put this summation of x squared over n. All right. You will not be penalized. All right. Uh huh. Oh, so you're talking about this formula here. Yes, these other formulas, as I'll show you, you each value you're subtracting by the mean, then you square and then you total up. Right? This is the other formula. Now for this formula, it's just square each number, then get the total. All right. Yes. Okay, so here we say 12 minus 1. Let me zoom in so that we're seeing this. Yes. 12 minus 1, that is 11. 242 squared, what do we get? Then when you divide it by 12, Okay. Yes, that's what I also got. Okay, when you do 242 squared, then divide by 12, you get 4,088. Just repeat that number again. 4,880, right? Point what again? Okay, we can just end to point three. Okay. Usually with this type of questions, colleagues, leave to two decimal places so that you make your life easy. Okay. Don't put five decimal places or whatever. Two or one decimal place is okay. So 4,920 minus 4,088.3. Huh? 13.7. 39. Okay, 39.7. Okay. So 39%. 39.7 divided by 11. 3, 3.6. Yes. So as I said earlier, a small standard deviation in this context for this question here, it means the sales were not fluctuating that year. Okay. The sales are not fluctuating that much that year. They are very close to the mean. All right. If we got a big standard deviation, a bigger number, it would have meant that the sales that year they were fluctuating. Maybe made a 1,000, made a 20,000, you made a 50, you made a 12. This in fluctuating sales. But in this case here, it's more like our sales was stable. Okay, they are very close to the mean, which you would want for your business. Okay, you wouldn't want your sales to be just fluctuating up and down. You want them in a stable range. Any questions, colleagues? Oh, wait. This is the variance. Ish, I forgot. This is the variance. The variance is just the standard deviation squared. Okay. We've calculated the variance here. Now, the standard deviation, we have to get the square root over the variance. Right? So we just get the square root of this. What's the square root of 3.9? 3.6? Yes, 1.9. Yes. Yes, that is our standard deviation. Any questions? Mm-hmm. Yes. No, no. Once you find one, no, not always. If you find one number, you pick that number by itself. Yes, you just pick it by yourself. Now, colleagues, I've got third years I have to meet by 1950. So is it okay if we pause here so that in our next class we're going to now use that other formula for the standard deviation, and then we move on to grouped data. Is that okay, colleagues? Let me ask first. Let me ask everybody, because others may say, "Ah, sir, we still want to continue learning. Forget about the third years." Madam Bethel, is that okay? Madam Betha, is that okay? Okay. Mr. Boniface, is that okay?